Hi guys, let's have a look at improper integrals today. Okay, so under improper integrals, we're going to have a look at three specific cases. Okay, the first case is if f of x is continuous on the interval a to infinity. So the closed interval from a and open interval on the infinity side. Okay, then what the integral is gonna look like, if that is the case, so you can see a to infinity f of x dx is gonna be the limit, okay, as b goes to infinity from a to b f of x dx. Okay, that's our first case. And remember, a is going to be a number. Okay, so next case is if f of x is continuous on negative infinity. It's from negative infinity, open interval, to b, closed interval. Then the integral from negative infinity to b f of x dx is going to be equal to the limit as a goes to negative infinity, integral from a to b f of x dx. Okay, now for our third case, what that is going to look like is if f of x is continuous on from negative infinity to infinity, both open intervals. Okay, so negative infinity to infinity f of x dx is going to be equal to the limit from, let me just erase this integral, so the limit as b goes to negative infinity of the integral from b to c f of x plus the limit as a goes to infinity from c to a of f of x, remember dx, make sure I put the dx also over there, f of x dx. Okay guys, now let's have a look at a couple of examples with all these three cases to see how they come into play. Okay, so for the first example, make sure you take a note of this formula because we're going to be looking at this formula first. Okay, so some examples. Say we've been given to find the integral of definite integral from 0 to infinity of e to the negative 2x dx. Okay, first step is recognizing that it matches with the first formula. As you can see, it's a definite integral from the number to infinity. Okay, next step is to look what our formula says. It says that integral would be the limit as b goes to infinity from a. Now a is going to be, in this case, 0. Okay, from 0 to b, and what is f of x? It's going to be e to the negative 2x dx. Now it's time to solve this. Okay, the next step would be the limit as b goes to infinity. Okay, so finding the integral of this first. We know the integral of e to the negative 2x it's just going to be e to the negative 2x over negative 2. Okay, so that's because that's the because we have that constant in front of x, the negative 2 is going to come down. Okay, remember it's a definite integral, right? So we're going to make sure we put the bounds over there. Okay, so the limit as b goes to infinity. Now we're going to plug in the b. Okay, so e to the negative 2 b over, so we can bring the negative sign in front, negative, okay, minus, oh, now remember, this minus is going to come again. when we do the minus sign. So the minus, right, that's going to make it plus. Okay, it's going to make it plus e to the negative 2 times 0 is 0. So it's just going to be 0 over negative over 2. Remember the negative sign already. We said that it's going to come up front. So it's going to be the limit as b goes to infinity. I'm going to put the bracket sign now, just not to get confused. Okay, so e to negative 2b. So it's going to be, let's try bringing this constant in the front. Okay, so e to the 0, we know it's 1. So half minus, because we have this minus sign over here, minus e to the negative 2b over 2. Okay, now with what comes, it's time to plug in our infinity, whatever our b value is, and we know that's our infinity, right? So it's going to be half, because we're trying to find the limit, right, as it goes to infinity. So half minus e to the infinity, remember it's going to be half to and divided by 2, right? Remember? Okay, so it's going to be e to the infinity. We know if we look at the graph of e to the x, right, and we know as it goes to infinity, it gets to 0. It gets closer and closer to 0. So this is just half minus 0, which is half. Okay, so that is our answer, guys. So when we're finding improper integral, it's kind of like finding a value. Okay, whether it's a specific value or if it's infinity or negative infinity. Okay, now let's have a look at an example with our second case. Okay, if f(x) is continuous on negative infinity to b. Okay, so that's what our formula is going to look like. Now let's go and put in our let's have a look at the example that kind of shows this. Okay, so from integral from negative infinity to negative 1 dx over cube root of x. Okay, first step, recognizing that this looks like our second formula. Second step, doing the putting in the value. So limit as b goes to infinity from b to negative 1 dx over square root of x. Okay, now then the limit as b goes to infinity, negative infinity, right? Yes, it's negative infinity. It's not just infinity, guys. Let's make sure we fix that. Then b to negative 1. We could also write this down. Remember, it was cube root, not square root, right? So x to the negative 1/3 dx. So it's gonna be the limit as b goes to negative infinity. Now finding the integral of this, right? So the x to the negative 1/3, it's just normal integration. So that integral will be x to the 2/3. Okay, and 3/2 would come in the front. Okay, from b to negative 1 to b, right? Now plugging in our bounds, right? What we're gonna be left with is limit as b goes to negative infinity. Negative infinity, so 3 times negative 1 square over 1/3, right? That's just gonna give us a positive 1. Okay, so over 2 minus 3/2 b to the 2/3. Okay, now plugging in our negative infinity, right? It's gonna be 3/2 minus 3/2 infinity, negative infinity to the 2/3, right? So anything minus infinity, this is gonna give us infinity squared, negative infinity square, right? And then we're going to cube root it. So a number minus infinity, right? A number minus infinity, because this is going to be 3/2 infinity. Okay, so a number minus infinity is going to give us negative infinity. Okay, guys, so that's what our answer, because infinity is the larger value that's going to impact this answer, guys. So that's the answer to this question. Now looking at an example with our third case, let's say we've been given to find the integral from negative infinity to infinity Again, if you think I'm going a bit too fast, please leave a comment down, letting me know that I'm going a bit too fast. But I'm trying to show you guys a couple of, working with the main examples and cutting out all the fluff that is there. Okay, if you feel like if you know these problems, then you will get a bit basic understanding of how to actually work with these problems. Now, looking at the third case that we were where we saw negative infinity to infinity, right? So what this is gonna look like if we plug it into our formula. So the limit as b goes to negative infinity. Okay, from b to let's for this basic value, we know that it's let's choose a value that's good to work with, and 0 in this case, right? Since we're going from negative infinity, 0 is a good value to actually choose over here. Okay, so we can really choose some anything we want over here, but choosing 0, I feel like it's gonna be easy to solve the integral. So and now we're gonna add limit as b goes to infinity. Okay, as a goes to infinity. From 0, again, we're going to put that value over here, 0 to a x of x squared plus 1 over x squared plus 1 squared dx. Okay, now we see this x squared plus 1. Okay, to find the integral of that, we're going to do some u sum. So u equals to x squared plus 1, du equals to 2x dx, and bring the the 2x to the other side, so du over 2x equals dx. Du over 2x equals to dx. Okay, now putting in the the u sub value, so we're gonna get half. If you can see, there's a half over here, right? That's gonna come out, so it's gonna be half. Again, that we're gonna bring it all the way the half over here, so it's gonna be half limit as b goes to negative infinity. Negative infinity from b to 0. Okay, 1 over, because the x over here is going to cancel out that x when we plug it into our dx, right? It's going to just give me 1 over u squared plus, similarly with this also, it's going to be limit as b goes to a goes to infinity from 0 to a, 1 over u squared. Again, it's going to be du, remember? Now we could change the bounds, but let's just plug it in as it is. Let's plug in back our original u's and sub it back in. Okay, so half limit as b goes to negative infinity. Now we're going to plug in, now we know negative, so this is negative u to the negative u squared, right? So basically u to the negative 2, right? Now taking the integral of that is going to be negative u to the negative first from b to 0 plus limit as let's put the half outside of both these limits. Okay, as a goes to infinity, negative u to the negative first from 0 to a, put a bracket around that, and what this is going to lead us is limit as b goes to infinity. Now remember, I said that we're going to plug in back our u. Our u was x squared plus 1. Okay, so negative x squared plus 1, the negative first. Okay, oops. Plus limit as a goes to infinity, negative a squared plus 1 to negative first, plus 1, because the plus 1 is going to come afterwards. And remember, this is the integral from our bounds are b to 0. Do not forget our bounds are b to 0, and the bounds for this are 0 to a. Okay, now you see all this mess right now, kind of, again, doing our normal integration, plugging in the bounds. What we're gonna get in the end, right? I'm gonna write down the last two steps. We're gonna get negative 1 from this side and 1 from the other side, and we're gonna get the good old 0 as our answer, guys. Okay, so that's our answer. If you have any questions, please leave them down, and thank you so much, guys. Please like, share, and subscribe.